So we had a small introduction yesterday. Dr. Edita had introduced our team. So I am part of the Samiti Center of Excellence in Astrobiology. Myself and Sneha, the three you can see the remaining two we are in Mumbai right now. So it's something like as you know, we have a MSc Astrobiology and Space Sciences course. The space sciences, but basically we are space physicists. So before joining Amity, myself and Sneha, we both worked in ISRO. I was part of one of the payload, like Aditya L1 payload. There's a payload called PAPA, Plasma Analyzer Package for Aditya. It's something to deal with the radiation impacts. So like, to study how effective the electrons, how energy of the electrons, those things are dealt with. So basically, I worked on that before joining Amity. Before that, also I have done postdoc in China. Before I did my PhD from Indian Institute of Geomatics. It's one of the leading research institute in India in terms of geomagnetism, basically space geomagnetism. So it's not about Earth alone. So like other planets everywhere. So when you talk about Mars, Venus, and different every planet has their own intrinsic magnetic field and also the magnetic field which comes through from the sun. So there are different ways you can have everything on their own. So here I would like to stress upon like you are in a higher latitude. So basically like Ladakh for India, it's a higher latitude. When you talk about space physics, when you see sun, it seems to be quiet. You have light, particle, energy, radiation coming from the sun, and it's coming and hitting, and you don't understand the particles and energy of high energy. Like it's something like you see light daily, you see go out sun, you have this ultraviolet and other radiation infrared coming. Even you can't see much of it, but you can understand by your body, like it has can absorb your body or different parts. So it's fine. So apart from that, sun, you see it is quiet, but it is not quiet. Sun activity changes. Basically, the activity of sun changes means like they're like a human beings. When they are hyper, when they are angry, they spit out words and they get angry and they scold or something like that. So sun also it's something like it's quite active. It's not always quiet sun which you see, like it gives only sunlight and throughout the day, the sunlight and in the other hemisphere, the day, it keep on saying our earth is rotating, so you'll get the sunlight. So it is not the case always. So it can emit high energy particles and radiations. So there are so many impacts do use because of this high energy particles and radiation. So that impacts can be different. So if it is something, there is something concept called like Earth has a magnetic structure. So that is Earth has a major magnetic component. If the Earth has a magnetic structure, so like we have when you talk about geophysics, you must be knowing like we have our Earth outer core where we can produce magnetic field. So Earth is shielded by means of magnetosphere. We call it as magnetosphere. The Earth magnetic field which gets shielded. So basically our sphere is shielded in the way like we have a complete magnetic field. So what the major role of this magnetosphere is to shield high energy particles and radiation coming from the sun. So as you see sun, you don't realize that high energy particles, radiation are coming from the sun because thanks to this magnetosphere, it acts as a shield. So it doesn't allow the high energy particles and radiation to come into them. So when you talk about higher latitude like Ladakh, when you go to Arctic and Antarctic region, that is not the case. So you have a magnetic field line. So in school or colleges, you might have seen the lines of force starts from the North Pole and ends in the North. So during in high latitude places, the magnetic field lines are towards the Earth. So towards the Earth means it can come closer to the atmosphere. That's what you might have heard of the word aurora borealis. So aurora, the aurora is possible because like the high energy particles and radiation coming from the sun, they cannot penetrate to across the magnetic field lines. So Earth has something magnetic field lines, continuous magnetic field lines. They cannot cross through, cut through, and come to Earth. So it will take a path towards the magnetic field lines. So when it pass through towards the magnetic field lines, so it can reach us closer to our Earth atmosphere. It is doesn't mean like it can reach up to close to Earth, close to Earth. So it reaches close to our Earth atmosphere. So what happens is like our atmosphere, we have our neutral atoms. So neutral atoms like oxygen, nitrogen, other. So when this high energy particles follows through this line and comes to our closer atmosphere, where you have your neutral atoms. So basically in chemistry, when you talk about atoms, electrons, those atoms can get energy. So when they get energy in the sense like the electrons has their own orbit. So electrons, when you have atoms, protons and electrons are arranged in a particular orbit, so particular circle. So when this energy comes and hits this electron, the electron goes to the higher level. So there are different levels that electrons can proceed. So they go to the higher level. When they come back from the higher level to lower level, so they cannot be in the higher state for longer time. Till the energy radiation coming from the sun, it will be in higher level. After particular time, it has to. So something like you get energy. So you eat and you have so much energy. You go out, play, and you get exhausted. The energy will come to your normal level. In the similar way, the radiation, this gives energy to the neutral atoms. It goes to the higher state. And when they come back, they emit in the form of light. That's why you can see in higher latitude, like the term they call it as aurora, the colorful lights. So in the sky, you see it as a colorful lights. So that's what they see it as a colorful lights. And different colors refers to different atoms present there. So nitrogen has their own color, oxygen has their own color. That's why you can see in Ladakh. I don't think so. Now you can see this is possible when there is a geomagnetic storm. So when you talk about air and weather, you have a normal storm, something like you can see cyclone, storm, something like in higher range, like when you talk about sun, when you go to the outer space, when the geomagnetic field gets uh, distracted. So when your geomagnetic field of the earth is distracted, we call them as geomagnetic storm. It's not the natural normal storm which you see in day-to-day life in the earth. So basically what happens is like sun has a solar cycle activity. So like every 11 years, the sun has some cycle. They call it a solar cycle. So there is a concept called sunspot. So you might have heard of this terminology like sunspots or something. So the sunspot number keep on increasing after 5 to 6 years. It will go to the high and it comes to the low close to 11 years. So this cycle, they call it a solar cycle. So during this solar cycle, when there is no more number of sunspot, they call it as maximum, solar maximum. Solar maximum, so it's like you can consider it in the normal terminology, it's like angry sun. So during that period, you can find high energy of particles and radiation coming out of the sun when they are in the minimum, like one close to 1 2 years and close to 10 11 years, it is coming to the lower normal state of the sun. So it doesn't have much energy particle radiation coming up the sun. So major problem, why do we need to study this? Like during the solar maximum, when you talk about higher latitude analog sites, when you talk about Ladakh or something, the high energy particles and cosmic radiation can enter into the uh, earth atmosphere. So those study can help you in understanding how the sun behavior is there, how the energy comes and how energy goes and how it can basically modify our earth and magnetic field. So cosmic ray radiation, you must be aware like there are different cosmic ray radiation coming throughout the globe, earth and other, even you can see in other planets also. That also has a major role in studying this earth magnetic field and other magnetic field. So what happens is like sun, they have it is a huge ball of gas. Sun is not a solid structure, as you know, like earth is a solid structure, but sun is not a solid structure. Basically, it is a gaseous structure. So it is a gaseous structure, and the magnetic field line stretches out of the gaseous structure. When it stretches out, after there is a process called reconnection. The lines get reconnected and it comes out of the sun. When it comes out of the sun and it travels towards Earth and forms, when it comes and hit our Earth, we have our Earth magnetic field sheet, mantosphere as a sheet. When it comes and hits, it opens. Few magnetic field lines are open and the energy is deposited into the Earth. This way, it is very harmful. Why it's very harmful is something like now when we are talking about magnetic field or something, in there are huge magnetic storm happened in 1840s and 1860s where we have a major power breakout. So it can induce current on the air and it can affect the transformers. Basically, these high energy particles and radiation coming, it can induce high energy static electric field, and it can burn the transformer and powers outages there. Now, recently we did not expose to that much high big geomagnetic storm which can cause impact. It can come up to there. We have seen in the space. So in earlier days, what was the good thing? Like we are not much dependent on satellites. So nowadays, in every communication you see, like when you talk on phone or everything, every communication, every data, every analysis you do in space science or anywhere, you're highly dependent on you're highly dependent on the satellites. So what happens is like the satellites, many of the satellites will be away from the Earth magnetosphere. So there are a few satellites which are away from the Earth magnetosphere. Some of the satellites very close to the border. So magnetosphere border is there, satellites are there. Some are inside the magnetosphere. So what happens is like when the high energy particles coming and hitting radiations, our magnetosphere is compressed. By the way, compressed means your satellite is here. It is compressed means the magnetosphere go inside, but your satellite will be exposed to the high energy particles and radiation. What happens basically here, like all our satellites, you must be knowing that all our satellites depends on solar panel. Basically, what are the energy, what are the inside structure, whatever your information data you're getting, it works on the solar cell. Basically, solar source is the solar cell. Basically, the cell is the major power distribution for the satellite. So what happens is like it may not, the high energy particles and radiation may not affect your satellite. Basically, whatever your satellite you have a navigation satellite that sends information everywhere here and there. It may not affect your satellite, but satellite is to be small. But when you see the solar panel, which is which is fitted to the satellite, it stretches to the longer distance. So what happens like it affect the solar panel. So basically, these high energy particles and radiation can come and hit our solar panel. So basically, solar panel means it is the main source which can produce power for the satellite. So though the satellite doesn't fail, when there is high energy particles and radiation comes and hit our solar panel, basically it will disrupt. Basically, it will collapse. So there won't be efficient power to run the satellite. So you won't have communication. This is, we call it a space weather. So basically this study, the study between sun and earth, it's not about earth also, it is about Mars also, it is about different planets also. Some planets have magnetosphere, which can, when you talk about different planets, when you talk about analog sites and different planets, you must see like what is the magnetic field present there. So we, as I told, we have a magnetosphere shield in here. So different planet doesn't have magnetosphere also. When you're thinking to study that, so you must be able to understand like this much energy particle radiation is coming, going to hit the other planets, means how much destruction is going to happen, how it has washed out because of this high energy particles and radiation impacted there. So when you talk about different planets has the different causes of their own, different impact of their own from the sun. So when you talk about Earth, we call it as space weather. When you talk about other planets, it's like planetary science, planetary space physics. It becomes to the planetary level. So different planet, we call it as planetary space science. So here when it comes, that's what here, like you have a weather warning, like tomorrow it's going to rain. So tomorrow it's going to rain or something, you know, before itself, something like it's going to have a storm tomorrow. It is having to going to have a major storm, major rain or something else. So you have a prediction. So you'll be prepared accordingly. Some college, university, they give up for a holiday or something. So those are something called weather prediction. So similar way, we need to have the space weather prediction. So one of our committee main goal, like our team goal, is to have a space weather prediction center. So far in India, we don't have any of the space weather prediction center. We have it in US. So even though such, why we need a space weather prediction center is like when the energy or this coronal mass ejection, some mass is ejected from the sun, it takes 2 to 3 days to reach our Earth. So basically, it has to travel towards sun from sun. It reaches our Earth in 3 days or 2 to 3 days. So it takes 2 to 3 days means, so you can predict it before. So once it is emitted, it takes 2 to 3 days means you know the approximate time it is going to reach. So what you can do is like if the satellite is in the orbit and it is in the towards the line of this emission. So emission is coming from the sun and the satellite is in between sun and earth. So satellite can be moved apart. So it can be moved in the backside direction. Some satellite has the control, like we can move apart and you can do it in a different way. You can shut down this solar panel. If you have some way you can close the solar panel, it don't get disrupted. So like this. So those things are possible when you know when it is going to come. Basically, when this emission going to come, when it is going to come. So if you know. So there comes the space weather prediction. Basically, the space weather prediction comes here. So in that way, we are planning to set up a space weather prediction lab at Amity, maybe in 1 2 years. It's a huge task because whatever coming from the sun, you never know when it's going to come. So we don't have a satellite in between to track that sun, track the ejection coming from. We have many satellites observing from L1 point. L1 point is very close to the Earth. So when it's emitted from the sun, it has to travel towards. So the problem is like in the way it can be deflected by another emission coming from that. It won't come. Sometimes you will predict at particular time the emission is going to come, and you will be very much prepared, and the satellites are moved apart. Sometimes you may have the thing like it won't come and hit you. So it won't come and hit you. So that way it is there. So apart from that, in when you talk about Ladakh, you have this high energy particles, UV rays, cosmic rays. Those particles are directly penetrating. So that's what I told. Our magnetosphere acts as a shield. The high energy, when you go to the higher altitude, the magnetic lines of force and many things are coming directly. Directly it is coming. So you are exposed to the lines. So when we have the magnetic field lines, it's bunch of lines in the equator, basically. Equator, and this is close to the equator. We have our equator. Here, the equator of Earth is different from the Earth magnetic equator. So close to the equator is magnetic equator. It is close to our southern tip. It's close to Trivandrum. Before we had it at Tirunelveli and it moved towards Trivandrum. It is going further down. So in the equator, we have magnetic field lines very much bunched. So when you talk about Ladakh and higher latitude, the lines are coming towards close to the atmosphere. So that's why when you go on higher altitude and latitude also, latitude and altitudes are more important. So higher altitude, you have a direct nature that you go to higher altitude like Arctic, Antarctic, you are go directly exposing into the atmosphere where we don't have the shield of this magnetic. When you go to the higher altitude, in terms of height also, you have an atmosphere when you are at the lower altitude, you have the atmosphere to protect this UV rays and high energy cosmic rays. So UV rays, it is not doesn't mean like you need to go to Ladakh always. Something there are some countries which are in higher latitude and altitude also. You don't need to have a higher altitude also that time. So though that is not higher altitude, you will have the difference in energy radiation coming. So in Ladakh, you will have a higher exposure of UV rays, higher cosmic rays. But cosmic rays and UV rays are not much harmful in terms of body when you talk about your body interaction. But that can cause you like sometimes you have this turning of that red color patches in your face. That is the maximum this UV rays can create. Cosmic radiation doesn't have much impact, but the cosmic radiation coming to the higher altitude are better in understanding in terms of scientific field. It is better understanding like cosmic rays has some primary, secondary cosmic rays, where it is coming, how it is coming. So in this way, the study of cosmic rays and study of UV rays in the higher latitude is more important, and higher altitude is more important in understanding their how they behave, how they are different in equator and other region. You can't find this because it cannot reach up to our Earth surface. So that way, in higher altitude and staying in Ladakh, it's very good for you to get exposed to that. So by this, I try to conclude like what are the importance of space weather and how it has a direct impact in Ladakh and higher altitude. So if you're talking about Ladakh, it's about other planetary object also. When you talk about Mars analog, it's Ladakh. So studying there, how it is going to expose this high energy particles and radiation coming from the sun, and being a higher latitude, and this has a known futures coming. So you can resemble with the different planets and different studies. So by this, I would like to end. If you have anyone has any doubts, I can interact and talk anytime.
Hello,
Yes,
can you hear me, Selva?
yes. If
Yes,
anything, you
thank
have Now I can't hear you.
Hello.
I can't hear you now. Hello.
Yeah. 1 minute. I'll again switch off the video.
Yes, yes, yes. If anyone,
Anyone has any question? Can you hear me?
I can't hear anything else.
Hello. Hello.
Hello, yes, sir.
Anyone has any questions? Hello. Selva, can you hear us?
Hello, Silva, sir. Hello.
He's not answering.
I can hear you. I can hear you. You go ahead. Hello.
Renita ma'am, please ask the question.
Sorry, IRN. Selva, I have typed the question.
Yes, 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 yes. Who they do they use in the sense who they use? I just want to ask.
Do we use? Do we use?
Ma'am, I can't hear you. Yes, basically I asked both data. Okay, everything like ion and
Yes,
both datas are used. That's what I told when we the previous satellite which I worked on, Papa Plasma Analyzer package for Aditya. It's the integration of ions and electrons. So both ion it is just to understand that how it is there in the sun, coming from the sun, different atoms, different elements comes. So basically, it can trap both ions and electrons. Based on this mass spectrometer, they try to understand how the behavior of these ions and electrons. Hello.
Something I have to do for the next. Yes, I thought of that something only, but then time. We have a few recorded mistakes. On six.
Yes, the phone also got disconnected. I don't know. Maybe I can send the answers by typing later. I can't hear anything basically.
Selva, they'll put the question in the group, the Amaze group,
I'll answer
and
it.
over there.
Yeah, yeah. By the time Sneha will give the talk sometime, huh?
Yes,
I'll
yes, yes, yes.
and post the question in the group
He's
either.
going to join now.
Yes. Yes, ma'am. Sneha is ready here. She'll continue here only.
Yeah, yeah, 1 minute. But it's very.
அதுக்கு ஒரு காரணம் சொல்லுவோம். என்னன்னா ஃபேனுங்கிறவங்க ஜெயிச்சதுக்கு அப்புறம் கொண்டாடுறவங்க.
ஃப்ரெண்டுங்கிறவங்க ஜெயிக்க வச்சு பார்த்து கொண்டாடுறவங்க. இவங்களை ஜெயிக்க வச்சு பார்த்து கொண்டாடுறதுக்கு
Can you hear us, Selva?
I am here now, Sneha. Can hear now.
Okay, we can hear you.
Okay, should I start? Is it breaking or it is smooth?
Actually, the internet is not at all stable.
Yes, I understand because even when I'm talking, I feel that some issue is there. It's not so smooth.
Okay.
Yeah. Should I continue?
Maybe you. Yes, I think you can start.
Okay.
Okay, maybe you can start. Now it looks okay.
Okay. Fine. I'll start. If anything is there, just tell me.
I'll put a group, okay?
Now it's breaking, I think. Your voice is breaking.
Okay, I'll put it in the group if anything is there.
Okay. Yeah, fine. So, hello everyone, very good morning. And I'm so happy that you all have gathered there in Ladakh for our expedition, which is hosted by Amity University. And I hope you are having a good time and you guys got acclimatized with the conditions over there. Silva might have given you the brief introduction about us, that what is our background and all. So here I am. I am basically more into the ionosphere and magnetosphere coupling related studies that we do for Earth and as well as for other planets. So my tool, because this science is, yes, ma'am.
Sneha, just can you just give us 5 minutes? We'll connect to a different internet.
Okay, fine. Yeah. That's okay. I'll wait.
This one. Password. Should we say?
it also password change.
VY? L?
L and S-double-A at Leha 2020.
Lay?
2020.
Correct? Hello?
Hello? Am I audible?
Yes, ma'am, you are audible, ma'am.
Yes, there.
Hello here? Hello? Audible, no? Yes, Neha. You can
Yes.
continue then.
Should I start?
Yes, you can start.
Okay, so I'll be talking a little more about the ionosphere. So Silva might have taken you to the sun, and from sun, how and all things are coming to us and how we are protecting ourselves. That is what he might have talked about. So I'll be little coming towards Earth. That is the atmosphere of Earth, and there is a very unique layer that we have got in the atmosphere, which we call it as ionosphere. So why ionosphere is kind of important, we can say that because of ionosphere, all our radio communications are possible. So what I use is the very low frequency waves. These are the waves that range in 3 kilohertz to 30 kilohertz. So what happens here is that we all might know that different frequencies have different relation with the atmospheric layers. So if the frequency is very high, it just penetrates the atmosphere and it goes out, even if we send anything. Now with the very low frequency waves, if we are sending, say we are on Earth and we are sending this particular signal anywhere from the Earth, so it gets reflected back from the ionosphere and can be received in the again back to the ground. So it is kind of a reflection coming. So these particular very low frequency waves can be used for the long range communications. What happens is in this way, the lower region of the ionosphere and the surface of the earth, they act as a waveguide. So the radio waves can be guided in a waveguide. We call it as a earth ionosphere waveguide. So these particular waves, very low frequency waves, can be received thousands and thousands of kilometers away. Even if the start point is somewhere, in the high latitude, but in the low latitudes also we can receive those signals. So this is very unique, I can say, quantity of this very low frequency waves, which we can use for our scientific research. And these very low frequency waves, if people know that how antennas are built, we have people from NRSC, so they must be knowing that we use Nyquist theorem. So what happens is we do lambda by 2, lambda by 4, and we understand the height of the antennas. Now, these very low frequency waves, you do a little bit of math with it and can see that if we want to transmit these very low frequency waves, we need an antenna which is a few kilometers tall. So with arrays also, if we want to use the array also, the antennas are so tall that it cannot be built easily. What happens is every country, then what they do is they have built antenna by defense. So the very low frequency waves are being used by each and every country with their navy people or defense people. Why it is so important for them? Because these waves can also penetrate deeper into the sea or ocean. So the navy people or the army people, defense people, they communicate with their submarines through this very low frequency waves, and they have the transmitters. Now, as a scientist, what we do is that we put up a receiver antenna rather than a transmitter antenna, so we can receive all these signals. So this is about the artificial part of the artificial source of the very low frequency waves. Naturally, are these waves available? Yes. How? Because lightning activity is there. So lightning, if we see the power spectrum of a lightning strike, the peak of that lightning strike lies in the frequency range of 5 kilohertz to 10 kilohertz or 15 kilohertz. which exactly is the range of very low frequency waves. And we know that all over the globe, the lightning is available every time. If it is not in India, but somewhere in the globe, the lightning activities happen. And as I already mentioned, that these waves can travel hundreds and thousands of kilometers without any attenuation. It is very feeble attenuation that we can use these waves or receive these waves anywhere sitting on the earth. So this is how we can use very low frequency waves. Now, some may ask questions that we have satellites, but the satellite range, even the low Earth orbiting satellites, we know that they are about 300 kilometers. So the lower region of the ionosphere, which is 60 to 100 kilometer or 90 kilometers, say, it cannot be, directly as such monitored by the satellite continuously. The second thing is that the balloon experiments, if we talk, the balloons can go up to 40, 45 kilometers and not to the 60, 90 kilometers. So balloons also cannot be used. One of the early ways which scientists used to do is to have rocket sounding. So sounding rockets can be sent, and from 100 kilometer, they can deviate and come back. So these are kind of point observations that also cannot be used 24/7. So very low frequency waves is the kind of only unique tool which can give us continuous monitoring of the ionosphere without much of doing, because we, as I already said, that lightning is already always present. So the waves are there. It is just that we have to receive. Now, how that whole this measurement works. So what is it is like the wave, it will have a sky wave and a ground wave, two parts of the waves, that is sky and ground wave. And at the receiver, what we receive is the basically both the waves interfering with each other. So it is a constructive interference. We know that the amplitude increases. If it is destructive interference, the amplitude decreases. Now, for a 2 point on the earth, imagine 2 points anywhere on the earth, the ground wave will be same. It depends on the land, ocean, and all those parts. But as we know the topography of the our own earth, the ground wave for those 2 points are always same. Now, whatever changes happen in the ionosphere, suppose say there is a solar flare which is coming, which Silva Kumaran might have talked about. So if a solar flare is there, the ionosphere changes because the X-ray flux during the solar flare increases. Okay, and X-ray, we know that they come down to the D region of the ionosphere, that is 90-kilometer region. So there will be increase in the electron density. So that regional basic change causes the path length of the sky wave to change. So what we get at the receiver end will be different from the normal days, the quiet days we say in the geomagnetic storm language. So on the quiet days and on the specific occasions like solar flares, or say there is an eclipse, or geomagnetic storm is there. Even scientists have found that during the earthquake related studies also, there are some difference in the very low frequency wave amplitude and phase. So just by receiving amplitude and phase at the receiving end, we can tell what might have happened in the ionosphere, lower region of the ionosphere at that time. So this is all about the very low frequency waves. There are hundreds and hundreds of applications. One such application is also about the particle precipitation. So from the magnetosphere, if we know the structure of the magnetosphere, we have something called as radiation belt. Now, the radiation belt, it is unlike its name. It is not the radiation, but it's a particle population in that particular region, whereas very high energetic electrons and protons are located, and that is being trapped by our Earth's magnetic field. So these particles are always there, and suppose something is happening from the sun, the particles may go out of that particular range, that is the radiation belt, or sometimes they can penetrate, they can come down to the atmosphere. Now, this high energy particles, when they come down to the atmosphere, that time also they react with the ionospheric constituents over there. And during that time also, the VLF can tell us that what is exactly happening during that period of time. So the particle precipitation studies also can be done by using very low frequency waves. So there are so many applications related to very low frequency waves. And in India, our previous institute, Indian Institute of Geomagnetism, where I did my PhD, my guide had 3 antennas located in Allahabad, Varanasi, and Nainital. There are antennas by somebody from Lucknow University and in Kolkata also. But at the lower part of the India, we don't have as such very low frequency waves receiver antenna. The reason being that in the ionosphere, the equatorial ionosphere is different from the high latitude and mid latitude ionosphere. So I am going to set up one such VLF antenna in Amit University, Mumbai now. And as far as I understand, because when I was there in VSSC, there also I tried to establish, we worked on the very low frequency wave receiver antenna. So in the exact tip of VSSC is at the Trivandrum. There also we are trying to set up one such antenna to understand. So it will give very low frequency wave, will give the lower region of the ionosphere. Then we have ionosondes, we have TEC, we have satellite measurements. So it gives whole spectrum of the ionosphere. So this is about Earth. Now, after knowing the Earth's ionosphere and magnetosphere, we can relate it to the planetary ionospheres or planetary atmosphere. So that is what is been done right now. So whenever we have a planetary mission, the atmospheric data is always collected and we try to understand the ionosphere, because this is also one of the important aspect of the astrobiology. Why? Because it may happen that the surface, there can be ingredients which are okay with the surface, but the atmosphere is not supporting. Like on Earth, as Dr. Silva might have mentioned, that as we have magnetosphere, the atmosphere is protected in a way. So atmospheric constituents are there because the magnetosphere is there, and these whatever particles coming from sun, they are not harming our atmosphere. So for other planets also, we have to take into consideration whether the magnetic field is there, or the magnetic field is feeble, or it is strong enough that it can hold an atmosphere over there. And if atmosphere is there and the surface is also having the proper topography, proper ingredients, everything in place to have a life there. So these aspects also come into astrobiology when we look for a life in a different planet. For an example, if we look at Venus, Venus has a very thick cloud cover, but the clouds are made up of sulfuric acid. So we don't know whether the sulfuric acid clouds and the atmosphere over there is, complementing if any life was there, or it can be there in future. So ionospheric studies and atmospheric studies are also equally important when we talk about all these things. As I mentioned previously, that the particles can penetrate, they can actually come down to the atmosphere. They can come down to 20 kilometers. So it can directly come to the troposphere of the atmosphere, these high energy particles. And these we call as killer electrons. So if they come down to the atmosphere, they can react with the atmospheric constituents and they can produce odd nitrogen and odd hydrogen. This odd nitrogen then can lead to climate change. So this is also connected to the climate change in the Earth's atmosphere. So there are many different aspects with one particular experiment that we can carry out. It is just that we have to pinpoint which aspect we want to know. The particle precipitation studies, if you know the South Atlantic anomaly, if you have heard about it, near the South Africa, there is a big region where, the radiations, they call it as the radiations can come down so heavily that we cannot have um, human habitat over there because the particles can directly come down to the atmosphere. It is that kind of region on Earth itself. Regarding the radiations, so because we have the particles directly coming in at the high latitudes, the particle can, as I told, that they can react with the atmosphere. The atmosphere at times can be thinned over there, and the radiations which are getting absorbed in the atmosphere, they can also come down to the surface, which are, unwanted, kind of say UV rays or those kind of things. So something which is coming and directly attacking our ozone layer, we have to be very cautious about those particles. So I study basically when and all such event happen, and whether they can come down to the atmosphere or they can go out in the magnetosphere itself. So this is what I study, and I make use of very low frequency waves to study all these things. So I think now I can ask if anybody has any questions regarding this particular, because this is very interesting and it is relatively, little different from the people who have gathered over there. That's what I feel. So any questions over there, Renita ma'am?
Yes, yes, sir. Khushi has a question.
Yes. Khushi, are you there?
She's typing it.
Okay, she's typing it. Okay, okay, fine. How is Dr. Nirmala today? She was not well yesterday, no? How she is today?
Can you hear her?
Yes, yes, I can hear you. Can you hear me?
Yes, yes. She is fine.
Okay.
All good today. Much
Oh.
better.
Nice, nice.
And
Anybody
we
else now? Everybody got acclimatized?
They are getting.
Okay.
Hopefully today they.
Uh-huh. Nice. I have not received yet the Khushi's question. I can't see in the chat box.
When Prabjot has asked a question, not in the chat box, in the message, WhatsApp.
In WhatsApp.
It's amazing.
So I was actually looking at chat. Okay. IRNSS data for studying ionosphere and ionic perturbations. I have in some point of time, I have used IRNSS data, but because it is always the 90 kilometer and below, that is the region which I use. It is kind of a supporting data for me. IRNSS data is a kind of complementing data when I want to see the whole spectrum, whole region of the ionosphere. So I make use of it as a complementary data to very low frequency waves. Okay.
Sneha, there's a second question.
How
By
Martian storms.
there is
Also one of the questions I received. Dr. Prabjot is asking how Martian atmosphere is affected by magnetic storms. So yes, on Mars, basically the same thing happens. The Martian atmosphere also, as Dr. Silva might have mentioned, that there are coronal mass ejections wherein all the energetic particles can directly come down to the atmosphere and then interact with it. So what they do is, if there are electrons or ion, depending upon the charge, they actually interact with the Martian constituents, atmospheric constituents, and they change the atmospheric chemistry over there for a period of time. And also on Mars, I believe that you might have heard about the sandstorms and all. So that is also one of the things where, the particles which actually, if they happen to reach at the surface, they directly interact with the surface constituent, and they make kind of a storm kind of thing. So yes, Martian atmosphere, all the surface, all the planets are in a way get affected by the sun solar particles and the solar radiations. Khushi is asking me, my question is, as you mentioned, the magnetic field is important for life, but can't it be possible that life could be present without any magnetic field like the early Earth, or we can say the organism is only dependent on radiation to grow only? Khushi, I'm not telling that the magnetic field is important for life. What I am all saying is that the magnetic field is protecting our atmosphere, and our atmosphere is important for our life. So magnetic field is kind of proxy, which is, complementing our life. If magnetic field is not there on Earth, what can happen is all these energetic radiations and energetic particles, they can directly interact with the constituents, atmospheric constituents, and in no time our atmosphere will vanish. So if you have seen in our Earth itself, the polar regions, in polar regions, because the magnetic field lines are open, the particles have direct entry to the atmosphere, and that is the reason that we have a very feeble atmosphere at the poles. So magnetic field is not supporting the life directly, but the magnetic field is in a way, it is helping to protect our atmosphere. Also on Earth, there are species, there are birds which can sense the magnetic field. So some of the life, like birds who use magnetic field to, locate or direct their way, they use magnetic field. So in a times of geomagnetic storms, where, the magnetic field fluctuates, we have seen there are cases, they have observed that the migrating birds actually lose their way. So the magnetic field actually affects these kind of lives also, not the whole life, maybe not the microorganisms, which can actually, sustain in extreme conditions, but the life which is, we say that, which has got little intelligence to survive on Earth. So I hope you are okay with my answer. Dr. Prabjot has asked which band antenna, Ka or Ku band antenna you are going to install at a meeting. Okay, this is very low frequency wave antenna. So this is not Ka or Ku. It is from the 3 kilohertz to 30 kilohertz. That is the receiver, and it is vertical electric field antenna basically. It is electric field antenna. VLF waves can also be detected with the magnetic loop antenna, which we have in Allahabad or other side. Maybe in VSSC also we are trying with the magnetic field loop antenna. What I am going to install is the electric field antenna, the vertical electric field antenna. Yeah.
Okay, anyone, any questions? More questions?
Any questions?
No, Sneha, no more questions.
Thank you. I hope it was some use.
Sneha, can you turn your video for some time so we can take a...
Yes, but I'm really sorry if I'm not photogenic today. uh, can you see me? Hi, everybody. Happy to see you all again today. I hope you're enjoying the weather and everything over there in Ladakh.
Yes, they are.
Yeah.
That's Nirmala. Can you see her?
Hi.
Okay, anyone, any more questions? Yes, Pete has one.
Yes, please. Hi, good morning.
Of the earth, which is right after every 10,000 or years.
Voice is breaking. Can you be a little louder?
The magnetic of earth is North Pole and South Pole. They reverse right after every 10,000 years probably.
Sorry, your voice is breaking, so I'm not able to get it. Can you write in chat box? I'll answer it. I got three question. He is asking, ma'am, the magnetic field of Earth switches poles after 10,000 years or so. Does this affect the life on Earth? Okay. Yes, Steve, you are correct that we have in past seen the magnetic reversals, and it did not actually vanish the complete. It did not affect the whole spectrum of life, but it did some with some species. So yes, in during these transitions, some life gets affected. It's true. And we have to see in future also such thing is happening, that in a way it will affect the whole the structure structure of the atmosphere, and in a way it will affect the life. It will, and it does. Any question?
Neha, anyone? Okay, no more questions.
Okay. I hope you have a wonderful day ahead. I wish you all the best.
Okay, bye-bye.
Bye. Have a nice day.
Okay. Pavitra, will you keep this on or we'll say 12:30 is on? What do we do? Mobile?
Yes, ma'am.
हाँ, अभी जो हमारा नेक्स्ट सेशन है ना वो 12 o'clock के बाद है, तो अभी हम लोग इसको लॉग आउट करके फिर बाद में स्विच ऑन कर ले 12 बजे 12:15 तक
Okay, ma'am.
चलेगा?
Okay, ma'am. Yes, ma'am.
ओके, ठीक है फिर, तो यही लिंक पे हम लोग ज्वाइन करेंगे 12:15 को.
Okay, ma'am.
ओके, थैंक यू.